A spring has a natural length of 10 meters. It takes 2 joules to stretch the spring to 15 meters. How much work would it take to stretch the spring from 15 meters to 20 meters? Okay, so this example is kind of interesting because in this case you don't have the same kind of given information that the previous examples did. So for instance, let's take a closer look at what's given here. So first off, this requirement of 2 joules to stretch the spring to 15 meters. So what you're being given there is an amount of work, because work is measured in joules, and usually we're given a force, and force is measured in newtons. So keep that in mind. And that's actually kind of interesting, because what's going to happen here is we know the amount of work completed by the spring is an integral from a to b of some function of force dx. And you may not have actually worked a problem like this before, and it's very interesting that you can still set this integral equal to a value and solve just like it's a regular equation, because ultimately this integral is going to work into a function, and that function might be linear, it might be quadratic, or any type of function, but then we can start using methods of solving to go from there. Let's see how that works out in this case. So a couple of things that we're told is that we have the natural length of 10 meters. It's taking 2 joules to stretch the spring to 15 meters. So to stretch this, not like from 10 to 15, but you're going from rest, because rest is at 10 meters. So we're going to go from rest to 5 meters. So 5 meters beyond rest. That's the 15 meters. All right, the function representing the force, of course, with springs, it's always the spring constant times the distance that it's already been stretched, dx, and that's equal to 2. And then I think this is something that we could work with at this point, because the constant k can come out of the integral, and we can integrate x with respect to x as x squared over 2, and then that integrates between 0 and 5. And then now I have k divided by 2 times, when I plug in 5 and 0, that would be 5 squared minus 0 squared, of course, is just 0. But so it looks like I have 25k over 2 equals 2, or k is 4 over 25. So I'm able to get that spring constant with the work given initially, and not just the force required to stretch it a certain distance. So just kind of flips the problem in reverse. But the next question is still basically the same. How much work would it take to stretch the spring from 15 meters to 20 meters? All right, so that amount of work in stretching from 15 meters to 20 meters, and keep in mind, rest is 10 meters, so this would be from 5 meters beyond rest to 10 meters beyond rest. The value k is 4 over 25 times x dx. And this is the same as the last step in the previous problems, it's just it took a little bit different way of arriving at the spring constant. So 4 over 25 times x squared over 2, integrated from 5 to 10. 2 goes into 4 twice. So this would be 2 over 25 times 10 squared minus 5 squared, which is 100 minus 25, or 75. Then it looks like 25 goes into 75 3 times, and this results in 6 joules of work.